Yeah, it started making stuff.
Thanks. Sorry. Such that A1 plus A2 plus A3 plus so on diverges. Proof or disproof the series sum from n equal to 2 to infinity of min an comma 1 over n log n base 2 diverges. So, okay, so I'll omit 2 from the base. I'll just assume that the log is always base 2. So notice that the last time we saw that this series n equal to 2 to infinity of 1 over n log n diverges, right? We use that trick where, uh, if you have, I'll just scroll up. We had this important theorem that, where is it? Yeah, that this A1 plus A2 plus A3 plus so on up to infinity converges if and only if this converges. So just take powers of 2 and then the appropriate constants. Um, so okay, so we had this the last time, and so from that we knew that this diverges because this is equivalent to saying that summation 2 to the n times 1 over 2 to the n times log 2 to the n diverges, but that's the same as saying summation 1 over n diverges, which is true because again you can apply the theorem again. Summation 2 to the n times 1 over 2 to the n diverges, which is to say summation of 1 diverges. And that is true.
If I have an idea, can you please verify if it is correct?
I can't hear you very well.
I'm saying if I have an idea, can you verify it if it
Yeah,
is
tell
right
me.
or wrong? So we can like in the summation either we have finitely, infinitely many of them of both of them, or finitely many of some one type of term and infinitely many of some other type of term.
Okay.
If we have infinitely many an's, then we can describe them in order p1, p2 till p. Uh, we can describe a sequence. And since we have that p1, p2 is a non-decreasing sequence and it is not bounded above, it will diverge.
That's not clear why that is true.
Like because if some non-decreasing sequence converges, then it has to be bounded
It's
above.
not clear why this subsequence is not bounded above, right?
Because like there are infinitely many of A1 terms of A1, the sequence.
Okay. So if you take 1 plus half plus 1/3 plus 1/4, and you just take the powers of 2, then it will converge, right?
Oh yes, yes.
Any non-decreasing sequence must diverge, right? A series of any non-decreasing sequence must diverge.
Uh,
Uh, no,
but
just
if
take powers of 2,
yes, yes.
reciprocals of powers of 2.
But
That
it
decreases.
diverges only if
That
it is
decreases,
not
right?
bounded above.
Oh, I'm so sorry.
It's supposed to be non-increasing.
You're right, this is non-increasing. Yeah, my fault. Yeah, otherwise this problem is of course false, right? I mean, it will always diverge. There's not much to do because then an is at least a1. So, yeah, and then the min, yeah. I mean, eventually, then the min of an and 1 over n log n will always be 1 over n log n. So,
Yeah, yeah.
yeah, yes, it's non-increasing. Yeah, I mean, that's also a problem, and the answer is yes, it is true. This is the challenge.
it won't diverge, right?
Why?
Because a subsequence of it diverges and it is of positive terms.
I don't understand. What do you mean?
Uh, like you know that both an and 1 by n log n diverge.
Sure.
So at least like when we take the min terms, at least one of the series will have infinite terms in this new series.
Yes.
And like there's some like since they belong to an diverging series and they are a subsequence of that sequence.
But a subsequence of a divergent series may converge. Like just take 1 plus half plus 1/3 and then just take 1 plus half plus 1/4 plus 1/8 plus 1/16.
Okay. Okay, subsequence of partial sums would diverge. Any subsequence of the partial sums would diverge.
No, then oh yes, yeah, subsequence of partial sum diverges. Yes, you're right. But here we won't get partial sums because we will skip terms. Right?
Yes.
Like at least one of them would have to have non-zero density. And like
Okay, and then what can you say from that?
I haven't okay, I haven't proved it. But like a dense subsequence must diverge.
I see what you mean. Think about it.
If like if some A, I'm saying like some either all terms are from an or all terms are from 1 by n log n, or some are from an and some are from 1 by n log n. If
Yes.
in the third case, like if some are from an and some are from 1 by n log n, we can like bound some ak with some logs. Like ak will be like some term ai after that is greater than some 1 by k log ai is greater than some 1 by I log I, and some, and it is for example take I age is smaller than 1 by j log j, and since we have that age is greater than ai, we will have that aj is greater than 1 by I log I, and it will be smaller than 1 by j log j, so we can count it in between, and in the
Oh,
sums we can replace like the a's with the terms of 1 by n log n.
but the n is very changing, right? It's not
uh,
like the n is from 1 to infinity in that line.
yes, yes, yes.
It will be weird. So it doesn't exactly. I mean, you can try it out if you want to in that way.
Okay, okay.
So I'll tell you this answer in 4 minutes, and then you can try to prove that. You know what? Let me just tell it to you right now. The answer is actually that there exists a sequence for which this actually converges. There exists. So the answer is actually that we can disprove this. Which act? So the density thing, I know it makes you feel like it. The answer should be yes. I mean, it threw me for a loop as well. But actually, the answer is that you can actually find a sequence, such a sequence for which this sum of min an comma 1 over n log n actually converges. So now the task is to find one such non-increasing sequence of positive reals such that there's some divergence, but this min converges. So let me just write that down meanwhile.
But can we just consider an to be 1 by n squared log n squared?
Wait, let me just write it down.
Okay.
1 over what?
Like we discussed about this problem that
Yeah,
1 by
but
n
you
log
need to
n
have
to the
a1
r.
plus a2 plus a3 to diverge. You need that.
Oh, yes, yes.
Yeah. Since you have this density thing in mind, note that if okay, so just I'm just giving you an intuitive idea to everyone about what density really means. It's like it's like eventually at least 50% of one of these sequences appears infinitely many times. It's not exactly formal, but that's the idea, that 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 for each n, either this min is an or 1 over n log n. So eventually, not only is it the case that one of them appears infinitely many times, it's also the case that one of them appears quite densely compared to the other. Well, it's not exactly true, but I, it's well, I don't want to define limit inferior and limit superior to formalize this, but that's the idea. And if you notice that if 1 over n log n is dense, then you will not be able to achieve this convergence. So you need to try to manipulate these AIs such that this sum converges. So maybe this min is almost always an, but then this min is so small that this summation converges. But then maybe whenever the min is actually 1 over n log n, an is large enough so that a1 plus a2 plus a3 etc. diverges. It's not very formal, but just think about it more. So. Yeah, if it wasn't positive, then yeah, sure. But unfortunately, it is positive. So what are you thinking about? Like, what are your ideas right now to prove convergence? I mean, prove this whole thing.
We need a dense subsequence of AIs to converge.
Uh, uh-huh.
Like the series to converge.
Yes. Well, it's not exactly that way.
And
The
like,
idea is
It's like,
like to cancel the 1 by n logins and then get a convergence sequence from it.
what do you mean by cancel 1/n log n?
Like I was telling right, like n is some k minus 1 by n login, the so that it is all so series of n is also convergent, divergent, and then we can just cancel out all the 1 by n logins that is.
No, no, wait. Sorry, it's not clear to me. What do you do to an so that we cancel 1/n log n? What do you do?
But it would become like negative, so it won't work, right? Because the sequence is defined on positive reacts.
Yes. So in general, think about how you can manipulate. I mean, what sort of sequences can you take such that this density is not exactly a non-zero number? Rather, think about things like these first to get some sort of a motivation for your solution. Again, I'm being very informed, so it's fine. But yeah. So what if you have something of this sort, right? So we have this along the line, uh, and this is zero, one, two, three, etc. And so for a long time, AI is bigger than this n log. So I don't know how n log n looks like. I assume it looks like this, right? And then maybe AI is initially larger, and then for a big proportion it becomes smaller, and then for an even bigger proportion it becomes larger, etc. Right? So then notice that between this and this, AI the min is always n log n, and then from here to here, the min is actually an for a larger time, and then between this and this last thing, the min is again 1/n log n for more time than AI, etc. So this is how you can sort of manipulate the densities to vary between 0 and 1. So depending on where you cut it off, the density, so basically the point, so maybe something like, so maybe for like two terms, 1/n log n is the min. And then for the next, I don't know, 8 terms, AI is the min. And then for the next, I don't know, 100 terms, 1/n log n is the min. The next, maybe I can just take 5, 10, 1,000 terms. Again, AI is the main. Well, okay, maybe not 1,000, maybe something even larger. My point is that if I do this sort of an alteration, then depending on what range of naturals you see from 1 to n, it might be the case that almost all of them have min equal to ai. And if I take some other n, then almost all of them have min equal to 1 over n log n. So this density can actually vary between 0 and 1 completely. I mean, taking everything in the range. I mean, crossing everything in the range. So, so yeah, so there's no fixed notion of density here because it's not, yeah, so that's what I'm trying to say. So it's not like the density thing actually is so bothersome. But yeah, this can be an idea for your solution.
Can you piecewise define the AN?
Sure, you can define an however you want. Yes, you can define it piecewise because, for example, whenever AI is larger than 1 over n log n, you will always benefit from taking it to be a constant like this, right? I mean, it will not change the second thing, but it will only make the first thing larger. So there's that. So you can
Like
define it.
I'm saying, it is 1 by n log n for some n, and it is 1 by n squared log n squared for some other n's, and mostly
Well,
it is 1 by n log n.
if it's mostly 1 by n log n, then if it's always mostly 1 over n log n, then
No,
this will
I'm not
probably.
talking about mostly like more all. I'm not talking about always. It is. I'm talking about the density.
Yeah, but if its density is non-zero always, then you cannot hope for convergence of the second thing. Yeah.
Like in the second part, like then for the second sequence series, we will have that mostly it is a convergent. Like there is a convergent sequence more density, so it would converge, right?
No, but it may not. But that's the problem that you don't know. But if you take 1 over n square log n square most of the times, then maybe the first thing also converges. So you have
Yes,
to be
yes,
careful.
yes. That comes.
I mean, if you take an to be 1 over n log n sometimes and 1 over n square
Yes, yes,
sometimes, then this is always equal to an.
yes, yes, yes.
So then, yeah, it won't work.
Wait, so it is true that a dense subsequence of a non-decreasing of a non-increasing would diverge, but here the density is not defined. Okay.
Yes. Yeah. So there is some notion of limit infimum and limit supremum. So here the limit infimum is basically you keep looking at the density from 1 to n and then keep taking a min of the first n densities and then take the limit. So that would be 0 here. And then limits. So basically between 1 and
Great.
n,
Yes, I have some idea. I
what?
think like if the second one converges, and since it is non-increasing, the second sequence will also be non-increasing sequence.
Yes.
So we will have that. It is bounded below, like it has an infimum,
What is bounded below?
like the second sequence. If it converges,
The sequence, not the series.
yes,
Okay. The
yes,
sequence.
yes.
Oh, sure.
So because if it is here time dating time
Okay.
very less, I
Yeah, yeah. Just so what I meant by density is this: between 1 to n, look at the fraction of num times an is the min. So let's call that f of n, right? So now note that this limit of f of n may not exist. It may not be something. It may not exist. That's the point, right? But but if you look at this sequence, so if you look at gn defined as min of f1, f2, etc., up to fn, then now note that this g is actually a non-decreasing sequence bounded below by 0. So this has a limit. This is called the limit inferior. And and then if you take a max, then it will again have a limit because it's bounded above by 1 and it's non-decreasing. And that's called limit superior. So I'm saying that you can sort of manage to find such function, such AI, such that this limit inferior is 0 and limit superior is 1. which is why you can manage to have these, which is why you can manage to make this convergent. Sorry. Because if the density is, if the limit inferior is more than zero, then it will diverge. Because then you're actually taking a dense sequence, which is always sort of dense, eventually. You don't have to exactly know what I'm talking about right now, but as long as you understand the intuition. But like what I'm trying again, I'll just mention it again. What I'm trying to say, suppose it's true that for n more than equal to 10 to the 5, it's always the case that between 1 and n, at least, I don't know, 5% of the mins are an. Then this second sequence will diverge. Because eventually it's always the case that 5% of the numbers that I'm taking in the min are an. So then this will diverge. So if you allow this, then this won't converge. This will diverge actually. So you can't allow something like this, which is why I'm saying you try to make these intervals such that 1 over n log n is min for, I don't know, one term, and then 1 over, I mean, an is min for 2 to the 10 terms, and then again 1 over n log n is min for 2 to the 2 to the 10 terms, something like that. Just make these so large, so much apart from each other that this density varies between 0 and 1 drastically, taking everything, and there's no limit. Because if you just take a geometric progression, it won't suffice. So if I make this 2 and then 4 and then 8, then both of these terms will always have 33% density. So this won't work. I mean, this whole thing is 4. The next thing is 8. So basically, if this is 1 over n log n, I want an to look like this. It's more for a very small interval and then less for a much larger interval than before, and then more for a much larger interval than before. So I'm exaggerating, but this is actually how it should look like. And then the next time again, it's the white part. The 1 over n log n is significantly.
But if we find some such n, how will we prove that it converges?
Well, I mean, this is not done yet. The point is that any such an that you find must look like this. Okay, not this because I've made it increasing somewhere, but look at it. Right? I mean, yeah, we're not done yet, but um, I mean, but at least that the idea is that you should know that the function that you're trying to find should look like this. But these are some boundaries. Let's call them. Oh, B0, B1, B2, B3, etc. The point is that B0 should be much less than B1, much less than B2, much less than B3.
But it will be positives like 1 by n log n.
What? Sorry, can you say that once more?
No,
Okay.
that
Of course, this notion of much less than is vague. That's the point. You need to think about it. So, okay, suppose such a function existed, can you sort of optimize how the blue line should look like? Like, can you sort of increase AI without affecting the second term?
Like one for a while and then like 1/B3 for a while.
Yeah, basically, yes, exactly. So the point is that it doesn't matter if I take this to be a constant, right? And then suddenly drop, and then even this starting point. I can take this to be a constant here. So white line is the 1 over n log n line. Because this
So
does
for
not
that,
affect
you
the
define
moon.
it piecewisely.
Yes. So basically, you have to be careful about this part. It's not clear how to define this, but this is the part where you can just take it to be constant and it doesn't really change anything for the second thing, and it only makes the and if the first thing diverged before, it diverges even now, right? So yeah.
But the thing is, like, how would you work on such B0, B1, and Bn?
Yes, but so try to write the sequences in
And
terms.
like, if the constants can't be the same too, they have to be different each time.
Which constants?
Like the constants defined there.
Uh, which constant? This B0, B1, B2 you're talking about?
No, no, no. Like you have defined a and to be some constant for a while, and then for some uh,
Yeah, these constants are
even
different. Sure.
yes,
Yeah.
yes. The constants have to be different because they're non-decreasing.
Yeah, but you know what these constants are, right? I mean, this is the point where you intersect. So this is 1 over B2 log B2. Okay?
Yes, yes.
So this is
And
1 over B2 log B2 for all, everything
yes,
in
yes,
between.
yes. It works. We need to work on such B1 and B2 such that it becomes convergent.
Yes, exactly. So how can you write the first term? So suppose we have some B0, B1, B2, B3. It's something, right? So how do you write the first thing? How do you write the second thing? How does it look like? What does A0 plus A1, it's A1 plus A2 plus A3, so on look like? Maybe I should have taken this to be B1, B2, B3. It's fine. We'll just put this. So what is this equal to?
You're talking about the A1 plus A2 plus A3.
What?
You're talking about the divergent sequence. A1.
Yes. So if my blue, if my A1, A2, A3, etc. looks like this, then how can you write A1 plus A2 plus A3 in terms of BI?
So you'll have like B3 by B2 log B2 and then B5 by B4 log B4 and those will be huge.
Will you get ratios? But
Like you'll have B3 many of those terms.
you have B3
Approximately.
minus B2 many of those terms. But
Yeah.
yeah, I mean, it's close to sure. Yeah. So yes, you're
Like
right.
declare some geometric progression, then declare some constant. You can do this.
We would we we would not like it to be a geometric progression for A1 plus A2 plus A3. Right.
Okay.
I mean, because we want it to diverge.
But we can like precisely define it like it is also some constant, like 1 by B2 log 2, and then 1 by BK log K.
Yes. So how do you write this sum in terms of PA?
So it is sum of some constants
No,
and
tell me more exactly. Don't not just qualitatively. Something in
okay,
terms of numbers.
okay.
And we'll, yeah. So like, what is the sum of the terms between this and this? Tell me that.
B3 minus B2 by B2 log B2.
Yes. So it's 1 over B2 log B2 for B3 minus B2 many terms, right? So and then this thing is again B1 minus B0 plus 1 over for 1 over B0 log B0 many terms. So But we also have more things, right? We still have this, right? And so okay, so okay, so we
This
can
would be a convergence subsequence
uh why is that so?
because like we're talking about the terminal density, so the minimum terms have to be convergent. If
Are
it
these
is,
terms?
yeah,
Yes, exactly.
it's
Yeah. So since we are hoping for these min terms to converge anyway, because this is the part of the min sequence, right? So then if we hope for this to converge and the entire series to diverge, we better hope that these constant things itself diverge. So it's not like we'll say something stronger if we want just the if we sort of ignore this part and we just want this plus whatever the next time it's constant, etc., add up to to infinity, right? So it suffices to show, and in fact, it's also necessary to show that this plus this so on diverges, right? So okay, so for this to diverge, it's sort of implied by saying that b1 minus sorry b1 minus b naught upon b naught log b naught plus b3 minus b2 upon b2 log 2 plus so on diverge. So how hard is it to make this diverge? Remember that I'm taking these to be far, far apart from each other, right? So this shouldn't be too hard to do, right?
yes, because like B1 is literally very large from B0, and
Exactly.
so yes,
Exact.
yes, so
Yeah.
it
So
would
yeah,
diverge.
yeah. I mean, this is huge, right? I mean, since B1 is much larger than B naught log B naught, it's not
Yes,
irrational to expect that this is more than one, for example. Even that is enough, right?
yes, yes.
It's enough to take this to be more than one. So it's enough for Bn to be something like more than, I don't know, Bn minus 1 plus Bn minus 1 log Bn minus 1. It's
Yes.
not something like this will work, right? That's the point. But okay, so
Or you can just take like Bn to be 2 log 2 into B1. It
yeah,
also
sure, we
kind of
could take
diverges.
something, yeah, but yeah, we could. Um, for now, let's just leave it this way, right? So let's just leave it by saying that this is not hard to do because B naught is much less than B1, much less than B2, much less than B3, etc. But we're not done yet because we still need the second thing to converge. And that's where the difficulty arises. This part is not hard. So, yeah. And so now that we've already managed these parts, how can you sort of optimize the blue part such that so this divergence we've already managed, right? So we don't need to think about it if this is true. Now the only part that remains is to show that this converges, right? And so how can you optimize the blue part such that this converging it's just like how we optimize this by making this constant, right? Can you optimize the other parts? Yeah.
Shouldn't it also be constant?
Yes, because you can sort of just decrease it, right? So instead of taking such a curve, I can decrease it to the bottom, right? Just drop it down like this. And so it does not affect these sums, this sum and this sum. Sorry, it's just a mess. Uh, let me redraw a little bit. So this was this, and okay, this increases at the end, but it's fine. And so we took these constants, and then later on we took this to be a constant, so on. But now in the decreasing part, we took it like this. But if I've already managed to if somehow I've already managed to make this divergent, Then to make the second thing convergent, it's only better if I replace this part with also constant, but here, right? Something like this. And then again here, something like this. Okay, this goes negative, but that's not okay.
We can't take it like that.
Yeah, I mean, something like this. You know what I mean.
Yeah.
And so now what can you say about? So now, what does the second thing look like? So what does this look like? Min summation n equal to 2 to infinity of min an 1 over n log n. Just from the diagram. Again, this is b naught, b1, b2, b3, etc. So what is it? So you want to add the min terms, right? This plus this plus this plus this, etc. So how do you write it?
We just write it like as it is summation.
Yeah.
Like from B0 to B1, it is then 1 by n log n is minimum. So we write it as summation B0 to B1 1 by n log n
What
plus,
is n here?
oh sorry, B0. The n varies from B0 to B1.
Yes, exactly.
Yes,
And
yes,
varies from b0 to,
yes,
let's
yes,
say b1 minus 1, but okay,
yes.
one of them. Yeah, we'll just include in next. We'll include this in the next one. So because I have to
And
include b0 somewhere.
B1 minus some epsilon. Yes.
Plus
Plus B2 minus B1 by
y.
Bn log n. Bn log
What
1.
what is n?
B1 log Bn.
b2 log b2.
Okay, that will be B1
It's the
log
second.
B1.
No, this is the smaller thing, right?
Oh, yes, yes.
Yeah,
B2
b2
log
log b2
B2. Yes, you are right.
plus summation n equal to b2 to b3 minus 1 of 1 over n log n, etc. Plus, just tell me one more term.
And then B4 minus B3 upon B4 log B4.
Good, right? So if I want this to converge, note that it suffices to show that this converges and this converges. I can just
Yes,
do it separately.
like some convergence sequences. We
Yes.
take some convergences. And clearly, like these B2 minus B1s are already
Wait. No. This is series and not sequences.
Yes, yes.
Yeah.
Oh, I am really forgetting the name.
Yeah. Tell me.
So we have like the second subsequence is already, the second series is already convergent.
Why?
We took it by the definition of minimum before in the assumption.
Uh, it's not clear to me because this diverges. Remember, we want this to diverge,
Yes,
and we
but we
want this to
also
converge.
we also took like the minimum terms. The sum of them have to be convergent.
Yeah, but we want that. I mean, I said that that should converge, right?
Yes, yes, yes.
Yeah, but we still don't know if it does. I mean, we still need to find these V0, V1, V2, etc. And we want this to converge as well. So now
I
we
mean,
have three things, right? Yeah, tell so that.
the second one is just 1 over log b2, 1 over log b4. Those are like, you can make that converge.
Yes, exactly. That's the point, right? So note that this is actually less than 1 over log b4. And because b4 minus b3 is less than b4. And so now this is not hard. Again, this is not hard to. So here, remember what did I do? I said that if B naught is much smaller than B1, much smaller than B2, then this will obviously diverge. By that same logic, note that this is less than 1 over log B2, this is less than 1 over log B4, etc. So if I take B2, B4, B6 to be very, very large, then this will converge, right? Say if I take B2 to be 2 to the 2 to the 2 to the n, like a tower of 2's, then even if you take a log, it's still very small. This reciprocal is still very small, right?
Yes, yes.
Yeah, so this will converge. So again, this part is again I could not hard to do. If I take each bn to be much much larger than any normal function, you know what I mean? Like, it's not or even this is enough. This itself is enough. Like if b naught is much much smaller than b1,
We
etc.
do not need to put many restrictions on B1 than B2.
Yeah, but note that this is not these restrictions are not that bad. You know?
Yes, yes.
Yeah.
So we have like some kind of freedom in the first.
Yes, we have a lot of freedom so far.
Yes.
So we need to satisfy three things. But for two of the things, we have so much freedom that we should hope that we can manage to do make this converge while not violating these two. So all we need to show is that there exists B naught, B1, B2 such that they're far apart and such that this converges. And so let me write it again somewhere. So it's summation b naught to b1 minus 1 of 1 over n log n plus summation. And obviously this is the hard part, right? Because this is not that obvious to manage. So we've reached the difficulty of the problem. N plus so on. Want it to converge. Everything we've done so far is without loss of generality almost everywhere, right? We've never assumed something very special about the types of AN that we're looking at. We just took everything to be very general. We just took these thresholds B0, B1, B2, which will exist, right? And and okay, okay. So we did say that this should be true, but that's still not. We've not lost much so far. Okay, so we've arrived here. So how will this converge? How do we make this converge?
We want the convergence sequence of this one by n. We
Uh,
need to find such convergence sequence of 1 by n log n. And then we can just we do not need to put many restrictions. We can just take some more larger n, and we will not have any much problem.
yes, yes, exactly. You're right. And so what do you do? So if you want convergence, it's the best to show that this is less than equal to something else that
Like
converges.
I'm saying 1 by n log n, so we can take n to be some perfect square.
But
And then
but
it,
these are but you need these to be intervals, remember?
oh yes, yes, yeah. We can just change the intervals. Like we can take some larger intervals then. Like if n is some perfect square, we have an infinitely large subsequence,
What
and
do you
we
mean
can
n is a perfect square? You mean BIs are perfect squares.
like yes, yes.
Okay.
Wait, doesn't works, right?
Yeah, it doesn't work. Yeah,
Yes, yes. It is defined on intervals. That's why it doesn't
yeah,
work.
that's the problem. Yeah. It's not like you can just skip terms and take long distances. You need big intervals, but you're also skipping big intervals. That's the point, right? So okay, b naught to b1 minus 1 is some interval, and then you can skip a large interval, but then you get an even larger interval than before. Like this is huge, right, compared to this skipped interval. And then, but then you can skip an even larger interval, etc. So you need to be careful about how you define these BIs. Let's be back. This is water. Coffee is back. Yeah, ideas. Good problem.
The idea is that the terms in the intervals, like there tend to be some terms of a convergent sequence.
Yes, yes, you want that. So if you want these to converge in some sense, but um, yeah, how do you do that?
So each term, like most of the terms, are mapped to uh, some terms of convergent sequence. Then it would only one.
Sorry, can you say that once more?
Like most of these terms would tend to be some terms of a convergent sequence,
Yeah, but
convergent series. Sorry,
yes, but now you
again.
need to be more exact. I need a specific B not P1.
I tried just dropping the log n in like less than 1/n, but that's way too weak. So then, like,
Yeah, because you'll get something like log of B1 by B not P1,
yeah,
right? Yeah, that's
yeah.
Yeah, like, can we just try to get n is going to be the first sum to be all the terms to be smaller than some 1 by k squared log k squared. But no, it doesn't kind of. It becomes a constant then kind of if you try to approximate the sum.
you can think about it. So if you want to go back and see how large you can take B naught, B1, B2, we could do that as well. So note from here that if we want this sum to converge, then then it suffices to sort of take um, So it's fine if log b2 is something like rather log b2k is something like uh, 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 k log square k, right? Because we know that 1 over summation, I mean summation 1 over k log square k converges. So so it suffices to take uh, 2 raised to this. Yeah. Just an example.
Oh, we can consider like the integral of 1 over x log x. That'll be like log log, and I think that gives us enough space.
Uh, Maybe. So exactly what are you saying? What is this less than?
Like log log b1 minus log log b naught.
Um, why is that so? Because the integral is. I just want to be precise whether it's more than or less than. Okay, for now, let's just say approximately. So integral of 1 over x log x is log log x, right? Because just take log x to be k. Yeah, u.
Yeah.
Yes. So this is like log log b naught, b1 minus log log b naught. Uh-huh.
Mm,
Plus.
It tends to be more approximate as n gets larger.
What?
It tends to be more approximate as n gets larger.
Mhm. I mean, sure. I mean, I you can always say this is less than twice of this. It doesn't really matter. Eventually, this will be true, so it's fine. Yeah, you're right. That is approximately even more. Yeah, yeah, you're right. Maybe this is enough, but why is it enough? So, does everybody know that the integral of x, 1 over x log x is log log x? Just tell me if you don't know it. It's fine.
We can just integrate it. Or we can just take a substitution.
Yeah, you can just take this to be u, and so
Yes.
dx by x is du. So this is du by u, and that's again log u. Yeah. This is another way to prove that 1 over n times log log n times, any finite number of times will diverge. And then if you have a raise to r in the end, then it will converge because you can replace it by integrals. I just specifically wanted to avoid integration, which I can avoid right now as well. But for now, let's keep it. Yeah, so have you found such a PN? So I'll just reconsider these parts. So notice what I said, that if log bk b2k is like k log maybe even k square, but it might be weak. So if it's something like k square, then this will converge. And if I take that to be k square, I mean, then maybe it's just better to take 2k square. So then if a bk is 2 raised to k square, then what is this equal to? This is 2 to the odd 2k plus square minus 2 to the 2k square over 2 to the 2k square log 2 to 2k square is just 2k square.
It becomes a convergence.
And this is, no, this will diverge, right? I mean, I can just cancel this out and this will become 2 raised to 4k plus 1, right? Minus 1. And this is exponential upon polynomial. So this diverges. This will converge. Just to make sure, am I doing this right? I mean, if I take bk to be something like this, then these both will be satisfied, right?
Yeah.
Yeah, okay. And does that work here? Like, what is log bk? So log of bk is k squared, so that log of that is 2 log k. So then what is log v1 minus log v0? It's just uh well, okay, it's this. So now we don't know if it is this good or not. Is this
Yeah.
enough? Yeah, that's the problem. This may not be enough.
It doesn't look like log is even enough. It should say like it should be like 1/0, 3/2, no? Like
Oh
it's
yeah.
2 log k.
Oh yeah, you're right. Yeah. Well, okay. You can sort of shift it. Instead of 1/0, you could write it as, I don't know, 2/1. Just the first term, you can just change it, right? Instead of 1/0, I can write it as 1/1. It doesn't matter. 5/4. And now does this converge or does this diverge?
We'll like the intervals will take up a time, so some dn gets more greater than dn minus 1. So the log also increases the time. It is not a log, it's non-infinite sequence.
Can you say that once more? I couldn't hear you very well.
Like if we consider this, then log, since you have that p, the intervals get bigger uh, as we make n more larger. So we would have that bn gets much greater than bn minus 1, then bn minus 1 was greater than b2, bn minus 1. So the log also gets larger,
Yes, that's the problem.
and
Yeah,
that it would be then
exactly. So,
convergent.
uh, divergent, you mean?
Yes, divergent.
Yeah. So, yeah. So that's the so here you're exactly right. That's the problem here. The problem here is that if Bn is very large compared to Bn minus one, then this will start to actually diverge, because the problem is that, remember that I can write this as approximately log b1 minus log b0 plus, log b3 minus log b2, etc. So if these differences start to increase, if this term is less than this term is less than this term, then the sum diverges. So now we have to be careful that we cannot allow this. It cannot be too large, right? So so now the difficulty is to try to balance the fact that here we want it to be large enough, and here we don't want it to be too large. So the question now reduces to balancing these two things. Is it clear what I'm trying to say? Just let me know if it's something not clear. Basically, I'm saying that if the gap between bn and b minus 1 is so large that this term is actually larger than this term, because b3 is so much larger than b1 and b0 and b2, that this term is larger than this plus this plus this.
Then
Then
we would try to make the interval that for which 1 by n log n was minimum very small. Then it would work really nice.
but then this won't work. You need to be careful about these two also.
Oh yes, yes. It's really great.
Yeah, it's a little complicated. It's yeah, it's not so straightforward. So of course, one over k, the k squared thing doesn't work, because the problem is that this log 3 over 2 plus log 5 over 4 so on actually diverges. This actually diverges. Can you tell me why? Is there a short proof?
Because like it gets larger with time.
No, it gets smaller. 7 by 6 is smaller than 5 by
Oh
4.
this oh, I thought you were considering B naught and B ones.
Why does this diverge?
Maybe just then see that log 3 by 2 then it gets closer to 1 as time, and the log n
No, log
by
3 by
n minus 1 gets closer to log
0.
1 as it.
Yeah, log 1 is 0.
Yes, yes.
So it's good that it. I
Yeah,
mean,
all,
that doesn't disprove it. Right?
yes, yes.
The point is that, log 1 plus x sort of behaves like x. That's the problem. It's very close in behavior. So this sort of behaves like half plus 1/4 plus 1/6 plus 1, which actually diverges.
Okay, so we just need like case like 2 to the k raised to 2 minus any epsilon would work, I guess.
Tell it to me again. Bn is
2 raised to k raised to like any number less than 2. Like
so
anything.
let's say 1.5. So why does this work? So
Because then you'll have like log of like 1 plus something like 1
no, but the
over root
1.5
n.
will come out. So again, you'll get log 2k plus 1 over log 2k.
Would you get like log
And
of 1 plus 1 over root n or something like that?
like
Or
your
not 1 over
words.
root n, like 1 over n to the 1 by 5 or something.
Isn't this n? Am I making a mistake?
Oh, okay. Yeah.
Right? Yeah. Sorry, you were saying Anurag?
I have said it will get more larger. Like the turns will get more larger.
Yeah, exactly. This is worse. I mean, it's not worse because initially there was a 2, but yeah, this doesn't help. So this function is too large, basically. I mean, it's not that large that this term is actually more than this term, but it's still the gap is still not enough. Like it's not decreasing fast enough. So this is not good enough. So let's go back to this. We wanted 1 over log b2 plus 1 over log b4, etc. to diverge, right? To diverge. What else did we want? We also wanted this, but this is not hard to do if I take B1 to be large enough. But let's see how large it should be, right? So, so it suffices for B2k plus 1 minus B2k over B2k log B2k. So, uh, so first of all, if B2k plus 1 is at least double of B2k, then I can write this as more than uh, uh, more than okay. No, yeah, let's not think of it in that way. So okay, so it suffices for B2k plus 1 to be more than B2k log B2k, right? Because then this will be 1 minus 1 over. Wait, does it suffice? Hmm. Well, I mean, if it's large enough, then it will suffice. But it was what? Okay, I mean, yeah, plus B2k. Let's say that.
It kind of budget in linear, then it would diverge against the first sound. It won't work nicely.
Say that once more.
Like you're trying to make P to K, Pn to be some kind of linear.
Linear.
Linear would not work, right? Because like you want it to be some.
I mean, it will work, right? I mean, linear. If bi
Then
is
it
a
kind of
linear function,
diverges 1 by x log x and then we just sum it. Kind of
but
becomes linear. We are trying to make it 1 by p log p to be some kind of p log p to be some kind of exponential that is greater than 1. Then it would work very nicely.
yes, yeah,
But we are trying to approximate to that exponential for some large intervals.
yes.
Like if we take an as like if we take bn as like 2 raised to f of n, then we need f of n plus 1 by f of n is kind of like 1 plus 1 by n raised to something greater than 1.
Bn is 2 raised to f of n, you're saying?
Yeah.
Okay.
Then we need f of n plus 1 by f of n to be like 1 plus something like 1 over n raised to something else. Like that 1 plus something has to converge, whatever that something is.
Where did you get the ratio of f of n plus 1 and f
Like
of n?
when you do log b naught, b.
Oh, yes, yes, you're right. So, sure. So we can take Bn to be 2 raised to Cn, let's say. Then what do we want? So, so, so what does this thing become? So, since this is like log over log, so minus log. So what this becomes log of Cn plus 1 over Cn, right? Well, actually, this becomes log of C1 over C naught plus log of C3 over C2, etc. Right? C4, etc. And what does this become? This becomes so we want this to converge. We also want 1 over C2 plus 1 over C4 plus so on to converge. And then we also want uh, this thing to diverge, which is let's write it in that way itself. So b2k plus 1 minus b2k over b2k log b2k to diverge. K to do
Clearly sees some kind of exponential.
what?
Clearly sees some kind of exponential. That's why 1 by c2 plus 1 by c4 converges, right?
Well, no, I mean it could be the square. I mean, ck could be k square. I
So
mean,
that's an
polynomial.
exponential.
How's k square and
Oh,
exponential?
sir. Polynomial or exponential. Both work, right?
Yeah, but you could also have something smaller than exponentials. So it's not like you need it to be exponential. Like, for example, I mean, it could, yeah, sure, it has to be, well, okay, it has to be, it doesn't have to be as big as k squared, it could be something smaller.
Okay, like
But k log k won't work, for example. Yeah.
But it has to be literally greater than be greater than k log k.
Uh, well, sure. So we can't expect ck to be k log k. Yes.
Yes, it has to be greater than that.
Mm, it's a little vague, but sure, okay. Yeah. It's not like it's not like if but okay, it's fine. Yeah, yeah, sure. For now, let's say it's more than k log k. You're right. Yeah. Yeah,
like
so that
we can use the like we can like recursively define Cn. Cn plus 1 by Cn is equal to 1 plus 1 by n raised to 1 plus anything small.
yes, so you're trying to actually manipulate and define ci from here, right?
Yeah, and like
Yeah.
that epsilon, like because it works, the other two hold for epsilon equals 0. So then it like should work.
Yes, so you're trying to define c2k plus 1 over c2k to be equal to 1 plus what was it?
1 over n to the 1 plus epsilon.
1 over e to the 1 plus epsilon. Something like this, right?
Yeah,
So that the log of this is just this part. And so this will converge.
yeah.
Yeah. Okay. So uh, but then so then what is ck actually? And what can you say about these two?
Like for epsilon equals 0, they converge. So then I guess.
Hmm, okay, let's see. Maybe it's convenient to write it as 2k so that I can take. Okay, but now c2k plus 1 is smaller than it was before.
Yeah, slightly smaller.
Yeah, so then we need to be careful about this, right? So why does this converge? So so you actually want this to be true for all n, is it?
Uh, mm, yeah, fine. I don't think.
If that's true, then wouldn't if I put the missing terms here, wouldn't that also converge? And so wouldn't
Okay.
summation 1 over n log n also converge?
Yeah.
Yeah. So there is a subtlety there. So can't expect it for all of them, but yeah, but we're very close.
Maybe then just note that 1 by c2 plus 1 by c4 converges.
What?
Then just we can just substitute cn to be like cn minus 1 into 1 plus 1 by n raised to power 1 plus epsilon, and then we can.
I'm not sure what your substitution is.
I'm like substituting each n with a, so we can get the form of c4 in terms of c3
I
and
mean,
so on.
sure, but it'll be weird, right? I mean, this doesn't exactly telescope.
But then just each term becomes like greater than 1 by x, then it kind of does not works.
Greater than 1 by x. So which
Yes.
terms become greater than 1 by x? It's
Like
not
if you
clear.
take C2 to be equal to C1 1 plus 1 by.
Yeah, but I don't want this may not hold for C even over C odd, right? I only want it to be true for C odd over C even. So it's not like C2 by C1 is equal to 1 plus 1 over 1 raised to 1 plus epsilon. I can't
Oh
put
no,
that.
I'm not like talking like you can just take it some random arbitrary constant.
Yeah, C exactly. You can take C2, C4, C6 to be anything, right?
Oh, but
Be- because
since we
then
have
this is not affected because this just tells you this ratio for independent things. Like this just tells you C1 by C0, C3 by C2, etc. I can still take C0, C2, C4 to be anything I want. And then take the odd terms, just manage the odd terms according to this. Right? C0, C1, I mean C2, C4 is still arbitrary. So actually I can choose C2, C4 to be anything right now. Even if I've made this restriction. Because I've only said what the odd term is corresponding to the even term before it. Does that make sense? So say I can take so I can define C2k to be k squared and C2k plus 1 to be k squared times 1 plus 1 over 2k is to 1 plus epsilon. This is fine, you know. So
Uh,
so this is satisfied and this is satisfied. You need to think about this. So it will be about 15 more minutes. Then we discuss. So instead of taking this, I can just write, just to be more general, I know I'm introducing more things, but I can take it such that 1 over d1 plus 1 over d2, etc. converges, right? This is enough. So anything other than, yeah, because because the point is that log of 1 plus x is less than x. Okay, this is base 2, so it's less than some constant and but it's fine. I mean, some delta. You need to, so since I can take C2, C4 to be arbitrary, I, let's just try to ensure that these two hold true, right? So if I take C2k to be in this manner, then what is this term? So what is B2k plus 1? What is B2k plus 1 minus B2k over B2k log B2k? What is this equal to?
it is just some like k by c.
Can you see that once more? This is
It is like some ik by e to
Right? You
I.
can write it exactly in terms of
Or
C.
you can just substitute it by the definition. We just substituted b k to be like 2 to the c k. Yes. And
Mhm.
then since we have it as a non-increasing, we can take out the c to the k and cancel it out. So we have some k by c to the k means j by c to the k, where j becomes larger with time.
Uh, Wait, what? So this is 2 raised to 1
C,
over dk minus 1 over c to the k. Right?
or maybe you can just take it out like since we have that b bk is uh, smaller than bk plus 1, we can
No,
then
bk is larger. B's are the thresholds, not the
yes,
sequence.
yes,
Yeah,
yes. Then we
yeah,
can just take out two. Yes, we can work it like this.
yeah. This is fine, right?
Yes,
Yeah, good.
and then we just want to be c2 to the kb like greater than we like to be greater than the numerator squared. Then it would work very nicely.
Yeah, so we want this to diverge. Yeah, you're right. So we want this to diverge, and we
Yes.
want this to converge. That's all we want right now.
So this to diverge, we should have that c2 okay by 2 like denominator by numerator would be like smaller than x, like smaller than k, then it would work.
Uh, it's not clear to me. Sorry. Can you say that once more?
Same like denominator by numerator should be smaller than x, then it can diverge easily.
Okay. So if which means you want this to be less than 1 by k, you're saying, right?
Yes, yes.
Yeah, but
No, better than
more greater than 1 by k. Sorry.
yes, yes.
But how? How do you do this? I mean, what do you do? How do you choose these DIs and CI?
Then maybe just know that dk also gets very larger.
What?
Then maybe just note that dk also get very larger as we approach the end. Since there's since the ratio of c has become also larger.
I don't understand what you want.
So will it be like 1 over the,
What?
um, like it'll be like c2k plus 2 raised to c2k plus 1 minus c2k, and that's like c2k by dk. It won't be
Yes,
like
you're
1
right.
over 2k.
Yes, you're right. Sorry, I made a mistake there. Yeah. So this should be it should be C2K by DK, right?
Yeah.
Yeah. Is this right? Yeah. This is right. Okay. Yeah. Yeah. This is right. Yeah. My fault. Sorry. This makes
And then
sense.
like this is definite like c2k equals k square and dk equals like k to the 1 plus epsilon should work.
Yeah. Why does this work? Because if I take CK to be C2K to be K squared and DK to be K raised to 1 plus epsilon, you said? Is this what you said?
Yeah, dk is like k raised to 1 plus epsilon, anything.
And C2K is K squared.
Yeah,
Okay. Then what is this equal to?
it's
So
2 raised to like k raised to 1 minus epsilon, yeah.
K squared. And this diverges because
Like it's 2 raised to something, it's basically.
exactly. and this converges because it's 1 over k raised to 1 plus epsilon, and this converges because it's 1 over k squared. And we're done. We wanted this to diverge. Yeah. So more precisely, we can take, more specifically, we can take k root k, and then this will be, or maybe we can just take k4 and k cube. So that would also work, right? Yeah, should work. And then this will be 2 raised to k or k to the 4. This diverges because it's an exponential. It's 2 raised to k upon polynomial, right? And so this summation will diverge. 1 over the summation of 1 over di converges because it's k cube, and 1 over c to k also converges because it's k cube. So with these in mind, how do the thresholds look like? Thresholds sort of look like so. So note that b2k looks like 2 raised to k raised to 4, while b2k plus 1 looks like um, 2 raised to k raised to 4 times 1 plus 1 over k cube. Right. So um, yes, this should work. I should just cross verify it later if this works. But it should. Okay, so the point of this large question was to, well, I guess the point was that you sort of just, so one major pick up from this is that you should always try to see that if the answer is converged. Okay, suppose you have arrived at the point where you think that the answer is that it converges. You need to first notice that if you have such a function, then you can always smooth it out so that it becomes constant on such intervals. Then you need the observation that if the entire sum diverges and this converges, then it better be the case that these constants diverge anyway. And then that leads to you actually being able to smooth out this part as well. And so now it's easier to deal with such a function because it's just a step function, right? Um, okay, yeah. The point is to try to so even though this it looks like these are like special functions, the point is that this is still without loss of generality, because if some other function works, then there is also such a function that works. So that's one pickup in these analysis sort of questions, is to try to not lose generality, but at the same time in some sense simplify the problem. I think that's one main key in such problems especially. And then just sort of keep simplifying, looking at patterns like this. Like initially it was hard to deal with this, but then these two are easy to deal with, but then you notice that this third thing causes a problem, and so then you modify it such that these two are easy, and then, well, basically you just keep simplifying such that everything eventually becomes easy to do. So from one thing easy to two things easy to three things easy. uh, yeah. Yeah, we're out of time. So, do you have questions?
Was that was that log log n? Was that the intended way to handle the thing?
Uh, well, basically, well, you don't need to know how to integrate, but yeah, as far as I remember, even the official solution, they do introduce log log.
Was
So,
it
so
a Putnam problem?
no, it's from this. I don't remember the name of the contest. It's let me search it. It's not good. No.
Oh, it looks like that.
Yeah, it does. Um, hold on. Yeah, it's from this. Put the source in the chat. It's a good problem. Also, by the way, you can simplify the problem by using the compression theorem we learned the last time, where, I mean, you can sort of get rid of logs. The point is that note that min of an comma 1 over n log n is also a decreasing sequence, non-increasing sequence. So then you can replace it with min 2 to the n, a2 to the n, and 1 over 2 n, right? It's that thing where a1 plus a2 converges if and only if a1 plus 2a2 plus 4a2
So
converges.
from
And
that,
this is,
for the solution used Cauchy condensation theorem.
yes, Cauchy condensation. Yes. So
Oh, I thought
this is easier to do. I mean, eventually it will be the same difficulty, but it's just easier to handle it. It's not like
yes, yes.
it's, yeah,
It gets very much easier.
yeah.
You
But
can
it,
just declare another sequence SI to be equal to.
yes, yeah. And then the official solution is also, yeah, the official solution goes into this log thing basically. So yeah, what basically we did. It's a little different actually, but it's fine. So they've written it in the forward direction. We sort of tried to go backwards because we didn't know how to do it. They've just written forwards. It's fine. Uh, yeah, I guess I'll try to put up more questions. Um,
But you change the like
what?
you tried to change the problem statement. Here it was strictly decreasing and you said just not decreasing.
Oh yeah, I mean it's not that different. So if you get a non-increasing sequence, then you can change it to make it decreasing. You can just sort of, so if there is such a non-increasing sequence, then you can sort of just add one half, one fourth, etc. Just add a convergent sequence to it, which
Your
decreases.
screen share has stopped, I guess.
Oh, so sorry. Uh,
Okay, no
okay,
problem.
so if A1, A2, A3 works, then A1 plus 1, A2 plus half, A3 plus 1/4 also works,
Yes,
right?
yes.
And then that's strictly. Yeah, I didn't want to. It doesn't matter.
Yes, you didn't use it anywhere in the problem.
Yeah. Okay. Any questions?
Pranav, can you stop calling?
Yeah. I think he's not around.
We don't think it will be.
Yeah. I mean, I guess we can just end the session and say, fine. I'll just leave. Okay. Bye.
Bye.